Hello, this is Mr. Molnar. I am trying something a little different since we're not going to do our traditional corrective instruction. This is going to be a little corrective instruction tutorial video for all my students so that they are able to correct their Chapter 10 test. And I'm going to try to change the screen. Obviously, this is the first time I'm doing something crazy and silly like this, but I'm going to try to change the screen over here so that you can see the test. Okay, so now it looks really weird because you're seeing a screen of a screen of a screen of a screen. Now, hopefully, you are seeing our Google slide presentation. So this is the Chapter 10 assessment, multiplying and dividing fractions, the corrective instruction. Next slide is just going to say, use this slideshow and the video, which I will link on here, to correct your test. You need to get it signed. It's due on Monday. The retake for this test will be Wednesday, March 23rd. It's the day before the last day of the quarter. So keep that in mind. This will be, besides your problem of the month, the last chance you have to change any grades that you might have for the quarter. So good luck with that. Let's just get started. Question number 1. Liam ordered corned beef sandwiches for a birthday party. During the party, the guests left 2/5 of the sandwiches. The next day, Liam shared the leftovers with his family, who ate half of the remaining sandwiches. What fraction of the sandwiches did Liam's family eat? Now you can see my work there. 2/5 times 1/2 equals 2/10. But let's talk about how to solve this problem. Starting with what is left over. 2/5 of the sandwiches is what is left over. It's what we're working with. The next day, Liam's family, which it doesn't matter if he has 9 siblings or he's an only child or anything like that, but his family is splitting half of the remaining sandwiches. So half of the 2/5 that we have. And that phrase, of the remaining sandwiches, and of the sandwiches, that word of should be a huge indicator that this is a multiplication problem. Since we're looking for half of what we have, we're taking 2/5 times 1/2. We multiply our numerators, we multiply our denominators to get the 2/10. We simplify that to 1/5, and don't forget your label because it is a word problem. So Liam's family, no matter how many people are in the family, is actually splitting 1/5 of the corned beef sandwich that was left over. And that's question number 1. Hopefully we have a better understanding there. Question number 2. Fiona sectioned off 1/4 of her backyard for a garden. Then she split the garden section into 3 parts for different flowers. Now part A was to draw a model to represent the space the flowers take up. So what I did to start, and it's going to be tough to see because it's a finished product, but I drew a rectangle. That would be their backyard, Fiona's backyard. I then cut that backyard into 4 vertical columns. 1, 2, 3, 4. So picture it without the lines going across left to right, but the yard is split into 4, 1, 2, 3, 4 sections. Now each of those sections I then split into 3 parts since we had 3 of the different flowers. So there's 1 part horizontally, 2 parts horizontally, and 3 parts horizontally. Now what we're looking for is the portion of the backyard for each type of flower. So each type of flower is going to get one of these small little sections. So one of these sections out of 12 total sections, so it would take up 1/12 of the backyard. Each type of flower would take up 1/12. So the problem that we're actually solving for this is 1/4 divided by 3. 1/4 of the backyard divided by 3 different parts for the flowers. So 1/4 divided by 3. If you start with a fraction, you finish with a fraction, so it would be equal to 1/12. Question number 3, with Kiva bought 3/4 of a pound of cabbage. If she bought potatoes that weighed 3 3/5 times as much as the cabbages, how much did the potatoes weigh? Hopefully you noticed that phrase times as much, which should hopefully indicate multiplication for that question. When you're multiplying with a mixed number, the important thing to remember is to change that 3 3/5 into 18/5. Now, the method that you use, whether it be the MAD method, the G method, the check method, whatever your teacher might have taught you, multiplying the denominator by the whole number, 5 times 3 is 15, plus 3 gives you 18, and we keep our same denominator, so that's where we got our 18/5 from. 3/4 is already a proper fraction, so we didn't need to change that. And 3/4 times 18/5, 3 times 18 was 54, 4 times 5 was 20. And then I did not show my work for this, but changing 54 20ths, you would have to divide 54 divided by 20. You would get 2 remainder 14. So that would be 2 and 14 20ths that you would then need to simplify to 2 and 7/10. So 14 20ths would have to change into 7/10. And then don't forget the label. We're talking about pounds of cabbage, so we're talking about pounds of potatoes. So Kiva would have bought 2 and 7/10 pounds of potatoes for question number 3. Moving on to question number 4, the area of the carpet below. Area indicates that we are going to be multiplying the length times the width. So we're going to multiply 2 2/3 times 3 3/4. Please ignore this work over on the side here. My substitute was trying to make an answer key, and I think he thought that we needed common denominators when doing that, when that is not the case. We only need common denominators when we're adding and subtracting fractions. Moving quickly through this one, changing 2 2/3 into an improper fraction would give us 8/3. Changing 3 3/4 to an improper fraction would give us 15/4. Again, if you're having a hard time changing mixed numbers to improper fractions, please check those blue and green glue-ins from our first section from our fractions unit, because those are the ones that will give us step-by-step how to do those types of problems. Now, to help myself on this problem, I did our little switcheroo tactic, our commutative property, where I flipped my numerators. I put the 15 on top of the 3, the 8 on top of the 4. Now, why did I do that? Because 15/3, 15 over 3, I know that I can simplify that to be 5 wholes. 15 divided by 3 is 5. And then 8/4, I know I can simplify 8 divided by 4 is 2. So the problem that I'm actually solving is 5 times 2, which is where I got my 10 square feet. Now, if you did not switch the numerators and you did 8 times 15, you should have gotten 120 as your new numerator. And 3 times 4 should give you 12 as your new denominator. So your answer might have been 120 twelfths. And if you did 120 divided by 12, you would still get 10 as your solution. So even if you didn't switch the numerators around, which for this problem was extremely helpful, you still were able to get 120 twelfths and simplify that into our 10 square feet. So, and of course, we already have our label, but don't forget that area is square area, so we needed the square feet, not just feet, as our label for number 4. Moving on. Question number 5 seemed to give us a little bit of trouble. Brianna is making 4 smoothies, and she needs half a gallon of orange juice. How much of a gallon of orange juice will be in each of the 4 smoothies? Now, she needs half a gallon to make 4 smoothies. So if you got any answer that was more than half a gallon, I don't think you were fully understanding the question, because it says she only needs half a gallon to make the 4 smoothies. You need to split that half gallon among the 4 smoothies. So you have a total of a half a gallon. You need to pour it equally into 4 different smoothies. So the problem we're doing is 1/2 divided by 4. Now again, you'll have to excuse my sub here. He used a different method here, dividing 1/2 by a whole number, but we should know it through our shortcut as 1/2 divided by 4. We can multiply the denominator times the whole number to get our new denominator. So our answer would be 1/8 of a gallon, which makes sense if we have 1/8 of a gallon in each of those smoothies. If we add 1/8 plus 1/8 plus 1/8 plus 1/8, since we have 4 smoothies, 1/8 plus 1/8 plus 1/8 plus 1/8 gives us 4/8, which is equal to half of a gallon, and that's what Branna had, was half of a gallon to make those. Now, a couple of people flipped these and did 4 divided by 1/2 and got the answer 8. And you might have seen a phrase that I used kind of commonly on this test was, does this make sense? And I'm hoping that now you can look back and see, one, if you're making smoothies, do you put 8 gallons of orange juice in them? That doesn't sound very reasonable. But two, if she only needs half a gallon, it's impossible for her to put 8 gallons of orange juice if she only needs half of a gallon. So please, please, please make sure you're rereading these questions and making sure your answer makes sense, because I think a lot of you could have caught that mistake before turning in your test. So be careful with those. Oh, and of course your label is gallon, since we're talking about gallon as our unit of measure. Continuing on. Question number 6. This is another area one, but we were more concerned with you being able to pick out the model of the area problem. So 3/4 of the length of the room and 4/5 of the width. So you'll see that phrase of the shows the area of, whoa, excuse me, let me shoot back here. Shows the area of the room. So again, of the, so these are all multiplication problems. 3/4 times 4/5. Now, in terms of the modeling, the big thing to remember is if one of them is going vertically, the other has to go horizontally. And if you used our strategy of counting the boxes across, 1, 2, 3, 4, and counting our boxes going down, 1, 2, 3, 4, 5, hopefully that helped you to realize that since it's 1, 2, 3, 4 going across for each of our models, you had to model the 3/4 going vertically. So this one could not have been 3/4 since it only models one of the 4 columns being drawn in. So this would model 1/4. So that would eliminate this first choice. Here we have 1, 2, 3, and they're not even colored in all the way going down. So this 3/4 would not work. And across it only models 2 going across, so that wouldn't work either with the 4/5. So the second one doesn't work here. Now, the third one, 1, 2, 3, 4 columns across, and it has 1, 2, 3 of them shaded. So the 3/4 was correctly modeled in this third option, as well as the fourth option and the fifth option. So these first two we were able to eliminate. Now we need to look at how 4/5 is being modeled. And 4/5 has to go the opposite direction. So since 3/4 went up and down, 4/5 has to go side to side. And we have 1, 2, 3, 4, 5. In our third option here, only 1, 2, 3 of the rows are completely shaded in across. So this would be modeling 3/4 times 3/5. But we're looking for 4/5, so now we've eliminated choice number 3. Choice number 4 here, we have 1, 2 of the fifths shaded in. And again, we need 4, so that eliminates choice number 4. So the only one that's left, and thankfully is correct, is our fifth choice here. We've got 3 columns for 3/4 and 1, 2, 3, 4 rows across 4/5. Now another way you could have checked this, remember our answer is the overlap. It's the boxes that have both the dashed lines and the shaded region. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them out of a total of 20 boxes. And if we multiplied 3/4 times 4/5, 3 times 4, our numerator would give us 12, and 4/5, our denominator would be 20. And this is actually the only one that has 12 of the boxes shaded in with dashed lines as well. So this was the only one that modeled the correct answer as well as the correct factors for our multiplication problem. So this was our answer here. Let's keep moving on to number 7 here. Finding the solution. The big thing, at least for my students, was understanding that rewriting 4 as a whole number means 4/1. I had a large number of students multiply 6 times 4. That would be if we were multiplying 1/6 times 1/4. But 1/4 is not the same as 4/1. For wholes, we would need a 1 as the denominator. So once we figure out that the whole number, we can put a 1 underneath it. It becomes a basic multiplication problem. 1 times 4 gives us 4 as the numerator. 6 times 1 gives us 6 as the denominator. So we had 4/6. Hopefully you were sharp enough to simplify that and divide it by 2/2 to get 2/3, which is our Homer-Simpson fraction, and the solution to that problem. So 1/6 times 4 would give you 2/3. Another way to do this would be to simply do repeated addition. You could do 1/6 plus 1/6 plus 1/6 plus 1/6. So you could add 1/6 4 times and you would get 4/6. And then again, make sure to simplify to 2/3. I'm going to take a quick water break. All right, on to Mr. Taylor. Collected 12 bushels of clovers on Friday. On Saturday, he collected 3/4 of the amount. So again, that phrase, of the amount, indicates that this is a multiplication problem. This is 12 times 3/4. Now, the difference on this problem is we needed to do a bar diagram. And way back at the beginning of this chapter, we talked about bar diagrams to help us find fractions of a whole number. So the bar diagram, the bar itself, the entire rectangle, is worth 12 bushels. We're cutting it into denominator pieces. So we have 4 as our denominator. So we cut it into 1, 2, 3, 4 pieces. What we then needed to determine is how big is each of those pieces. If the whole rectangle, the length of the rectangle is 12, each smaller box inside the rectangle had to be 3 bushels long. 3, 6, 9, 12. Just like at the beginning of the chapter, we did an activity, I believe it was pitches. A young lady threw 16 pitches and 3/4 of them were strikes. So we had to figure out that how many pitches long each of those is, which I know bushels and pitches are not labels, but for this situation, it kind of gives us an idea. Then we wanted 3/4 of the amount, so we wanted 1/4 and 1/4 and 1/4. We wanted 3 of the fourths. 3 plus 3 plus 3 gives us 9. So 3/4 of the amount would be 9 bushels for that one. And I didn't have a label, so you can yell at me on Monday after you've watched this video. And fine me. If you remember to yell at me on Monday, I'll give you $10 because I usually fine students for not labeling. Question number 9, finishing the model to represent the quotient. A lot of people were shading in some of the regions on this, and I wasn't quite sure what you were trying to show. But if you just solved using our shortcut, 7 divided by 1/6, remember our big discovery was that if we divide a whole number, so if we start with a whole number and divide by a fraction, our answer is a whole number because it wants to know how many pieces are you going to get. If you have 7 wholes and you cut them into 1/6 size pieces, how many pieces are you going to get? And so the answer would be 42. And I didn't write in all the numbers, but if you count each of the individual pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is exciting to hear me count to 42. 19, 20, 21, 22, 23, 20, 21. Sorry, I think I started on the wrong number there. Actually, I should be up to 28 over here. 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. It's really, I definitely messed up my counting here, but I promise if you count all those pieces, there's 42 of them. There's a lot of pressure to be counting on TV like this, even though I'm not technically on TV. My anxiety level is raising, so I'm just going to keep moving on here. But 42 pieces. If you got 1/42, it looks like you had the right idea. There were 42 total pieces, but each one is cut into 6ths. And again, we want to know how many pieces. When we're dividing into a whole number, we want to know how many pieces. there would be. Let's see, question number 10 with Kayleen. I love that name, Kayleen. Needs 2 cups of sugar to make her secret St. Patty's Day cookies. Part A wants to know, she discovered she only needs 2/3 of the amount. That phrase again, of the amount of sugar her recipe called for. Is the amount she needs more than, less than, or equal to 2 cups of sugar? Well, what I was looking for there was that you were going to need less than 2 cups of sugar if you only need 2/3 of the amount for the recipe. And I think a lot of people were misunderstanding. We were not looking for you to compare 2/3 and 2 cups. I'm fairly certain all of you understand that 2/3 is less than 2, and a lot of you put that into part B using pictures, numbers, or words to explain your answer. That was not what the question was asking. What the question is asking is, if Kayleen only needs 2/3 of her recipe, does she need more or less than 2 cups of sugar? Now, she needed less than 2 cups of sugar, and a large number of you did 2/3 times 2 and came up with 1 1/3 as your answer, and that was fantastic. If you proved it using numbers, or if you drew pictures, that was not a problem. I chose to use words here and just simply stated that since you're multiplying by a number less than 1, so that's the 2/3. 2/3 is less than 1, and when you multiply something by less than 1, you get a smaller answer. If you multiply by a number greater than 1, that's when you get bigger answers. So in this case, we had 2/3 of the recipe, so it's smaller than 1. We're reducing the recipe, so we're actually reducing the amount of sugar we're going to need for these super secret St. Patty's Day cookies. All right, question number 11. Seamus has 1/2 pound of gold coins. He wants to split it equally among his 5 leprechaun friends. Now, first of all, this was supposed to be intended to, Seamus was not getting to keep any of his gold coins, although I think some of you, if you came up with 1/12, then you modeled it correctly. I probably did give you credit, but just be aware that you were not supposed to be giving, or Seamus was not supposed to be keeping any of his gold coins. Now, he has 1/2 pound of gold coins, and he's splitting it equally, and that phrase, split it equally, should be a huge indicator that we are dividing. Now, when we're dividing with fractions, there's 2 choices. You could do 1/2 divided by 5, or you could do 5 divided by 1/2. The big thing to understand is, what are we splitting? Are we splitting leprechauns, or are we splitting gold coins? In this case, we're splitting gold coins, so we're going to do 1/2 divided by 5. So what I did was I drew a rectangle and I split it in half horizontally. So the top is a half and the bottom is a half. Now what I did was I lightly shaded, using my slanted lines here, that this is what Seamus started with. Seamus started with the half. He started with 1/2 pound of gold coins. And since he's splitting it equally among 5 leprechaun friends, I split it vertically, 1, 2, 3, 4, and then I had my 5th column here. So 5 different columns for each leprechaun, and ideally they are equal size, but obviously I'm not the best judge of that. And so since he started with 1/2, and each leprechaun is going to get just this little piece, when we're dividing a fraction by a whole number, the question is not how many pieces anymore. The question is how big, or what is the size of each piece. So if we're talking about 1 piece out of all these total pieces, each leprechaun is going to get 1/10 of a pound. Now, of a pound of gold coins, or however you might have phrased that, is fine, as long as you had this pound label. That was the big thing there, since we're talking about pounds of gold coins. If you came up with 10 pounds, it sounds like you might have done 5 divided by 1/2, in which case, again, if you reread the question and understand, Seamus only has 1/2 pound of gold coins, so it would be impossible for him to give 10 pounds to each of the leprechauns. And then the modeling, be careful. I did see a lot of people that modeled 5 divided by 1/2. They drew 5 rectangles and cut each one in half. That would be if you were splitting leprechauns, which sounds rather dangerous with St. Patrick's Day coming up. I don't think I would want to mess with this guy, and you guys see all the Fighting Irish, the logos in my room, so you don't want to mess with those guys. They're tough. All right, on to question number 12. Finish the model to represent the product of 2/3 times 3/5. Again, the big thing with this, just like the one earlier, is counting your boxes. So we've got 1, 2, 3, 4, 5 across the top, and 1, 2, 3 going down. Since it's 5 across the top, 1, 2, 3, 4, 5, that means that 3/5 is going to be modeled vertically. So we've got 1, 2, 3 columns that I shaded in with my red slanted lines. That would be my 3/5. 1, 2, 3 columns, 3 whole columns from top to bottom, shaded in to be 3/5. Now 2/3 would be horizontally, since 1, 2, 3, we have 3 rows going top to bottom, and we needed to shade in 2/3 of them, 2 of them. So I've got 1 going across here, 2 going across here for 2/3. My overlapping area is the one that has both colors, and you'll see I kind of outlined it here in blue. And I have 1, 2, 3, 4, 5, 6 boxes out of 15 boxes. Now, if you didn't write the answer in and you just modeled it, that was perfectly fine, as long as I could tell where your overlapped boxes were. If you just wrote the answer in and shaded in the answer, though, I did not accept that, as I was looking for you to be able to model 2/3 all the way across and 3/5 all the way up and down. So you did have to have both of those. Now, if your answer showed up over here, over here, over here, that did not necessarily matter. What mattered was you were able to model those fractions, both of those fractions, in our little area model here. Another quick little water break. You can check out that dancing leprechaun. All right, Mally sells rope licorice that is 6 feet long. McKean wants to make sections that are 1/3 of a foot long. Part A was to draw a model to help you solve. So again, what you needed to figure out, what are we splitting? Are we splitting the 6-foot rope licorice, or are we splitting the 1/3 foot long sections? The only thing we could be splitting in this section, or in this situation, is the 6 foot of rope licorice. Now, I drew each foot of licorice separately. It probably would be better to draw connected, but I've got 1, 2, 3, 4, 5, 6 boxes. That indicates the 6 feet. I like to draw them separately because then when I'm dividing it into thirds, I can cut them each into their own 3 pieces. So I've got 1, 2, 3 thirds in my first foot, 1, 2, 3 thirds in my second foot, third foot, fourth foot, fifth foot, sixth foot. The problem that we're actually solving is 6 divided by 1/3. 6 feet of rope rope licorice cut into third foot pieces. So 6 divided by 1/3, we could use our shortcut method where we multiply our whole number times our denominator to get 18. Because remember, when we're dividing a whole number by a fraction, the question we're asking is, how many pieces? We know how big each piece is going to be. Each piece is going to be 1/3 of a foot. What we want to know is, how many pieces are there going to be? So in this situation, 6 times 3 is 18. If I count each individual piece, which I'm not going to do because I tried to do that on an earlier slide and miscounted horribly up to 42. In this situation, we have 18, and I counted off 3, 6, 9, 12, 15, 18. So I did cheat a little bit by counting by threes. So each McKean would be able to make 18 sections that are 1/3 of a foot long. And we're on to our last one. Finally, choose 2 correct models that represent the quotient of 2 divided by 1/8. Now, much like our modeling question earlier, I'm going to kind of use some process of elimination. And the first thing I'm going to do is I'm going to look at my whole number, 2. So I'm starting with 2 whole somethings, pizzas, bananas. Let's talk bananas. I like bananas. So we're starting with 2 whole bananas. Now, because of that, I'm going to eliminate these bottom 2 choices. This choice here on the left, I guess choice number 5 we could call it, shows 1, 2, 3 whole boxes that are cut into 8 pieces, but there's 3 of them. This would be 3 divided by 1/8, so this bottom one, bottom left, no good. Now, chosen, and you can see as my sub was trying to create a key, he even thought about this one at first, as you can see the eraser marks here. This is really close. This was kind of a tricky answer here. This one actually represents 1, 2, 3, 4, 5, 6, 7, 8 holes divided into 2 pieces. So if we're counting pieces, we would actually get the same amount, but the modeled question here would be 8 divided by 1/2, because there are 8 holes, each of them cut into 1/2. And since we are starting with 2 holes, that eliminates this bottom right-hand choice as well. So these bottom 2 answers are no good. This has 3 holes, this one has 8, and we're looking for 2 divided by 1/8. So now and actually this one right above, our choice number 4, only has 1 hole. So we can also eliminate that one since we need to start with 2 whole pieces. So if we're looking for 2 correct answers and we've got 1, 2, only 3 choices where it shows 2 whole pieces or 2 whole bananas in this case. Now we're dividing them into 1/8 pieces. So now it became what you needed to do was count the number of pieces in each of the holes. So here we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. Each of them is cut into eighths here. Same thing here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this one was cut into eighth pieces as well. Over here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this top left-hand choice is wrong. This would be modeling 2 divided by 1/6. The last thing you could have done to check it, although probably would have given you a wrong answer down here, is you could have solved the problem. 2 divided by 1/8 would give you 16. There are 3 choices on here that actually have 16 total pieces. This, as we talked about before, this bottom right one also has 16 total pieces, but it has 8 holes to cut into halves. Excuse me. Oh, I almost made it through the whole thing without coughing. Next time with a cough drop. So down here, this bottom right-hand corner one has 16 pieces, but started with 8 holes. So this second one on the left and the first one on the right were our 2 correct answers for that question. I believe that was the last one. So I'm going to try to go back here to where we originally were. And there I am. So hopefully this helped. I know it's probably a pretty long video. I haven't checked the time on it yet. But as you're checking through, please feel free to skip through, rewind, go back to the ones you might have missed, go back to the ones that you've got but might have guessed on. Retakes will be Wednesday, March 23rd. You have to have your test graded or corrected, excuse me, by Monday, and you have to turn that in so I can check it with a parent's signature. And we'll do some small little reviews in class before we do that test. Hopefully the retakes go as well as the last one. I was really impressed. And again, this is the last test of the quarter, so you want to make sure that if you're unhappy with where you stand grade-wise, this is your last chance to kind of remedy that situation. So we'll see how this screencasting and this form of corrective instruction works. Maybe this is something we do again at a later date, or even better, maybe one of you guys can do this for me. That way I'm not up late and you don't have to look at my ugly mug. And you guys are probably much better at explaining this stuff than I am anyway. So this is Mr. Molnar saying good luck with everything, and hopefully I did a good job explaining those problems. If you have any questions, please come see me. And I'm going to try to hang this up, although it probably won't happen for a couple of minutes, and you might just see me staring blankly at this.